Welcome everyone. The question that is displayed on the screen it came in the CBSE 2025 set 1 question number 18B and it acts as the OR of 18A. Okay, so this is the questions from the ray optics and it is said a convex lens is kept coaxially on the left side of the concave mirror. Just see it is drawn here. This is the mirror, this is the mirror and this is the lens. Okay, at a distance 5 f from it. Okay, so the distance between the lens and the mirror, that is O1, O2. O1 is the pole of the concave mirror and O2 is the optical center of the lens. The distance between them is 5f, where f is the focal length of each of them. Okay. So if you think this is the positions of the focal of the concave mirror and that is f. Okay, and their focal lengths are same. But why I am doing this to show this, that is the focal length is positive for the lens but it is negative for the mirror. An object is kept at a distance 2f on the left side of the convex lens. Okay, here is the object I have placed here, object, and this is the object for the lens. So let us say this is the object 1, object 1. Okay, so after that, if it is placed at a distance 2f from the lens, so we can say simply and logically, if the object is placed at 2f, the image will be also obtained at 2f, inverted, equal in size. But if you are not satisfied, then I am doing this problem. Let us take, this is u2. What is u2? Object distance for the lens, and it is minus of 2f. Okay, focal length of the lens, that is we can say f2, and f2 is plus f because the focal length of the convex lens is always positive. Now if you want to find it out, what is v2, where the image will be obtained, that is a question mark, big question mark. And the equation for the lens, if I write, that is 1v2 minus of 1 divided by u2 equal to 1 divided by f2. Okay, so what is v2, we need to find it out, and we not applied what is the sign convention here. So the value of the v2, when it comes out, it is comes with the value along with the sign. So what is u2? U2 is minus 12. So let us put it minus 12, minus 12. And what is the value of the f2? F2 is f, so that is plus f. So from here 1 by v2 plus of 1 by 2f equal to 1 by f. So 1 by v2 equal to 1 by f minus of 1 by 2f. And I think if you do this calculation, you will get 1 by 12. Okay, from that, what is expected, what I have just told, that is if you place the object at 2f, the image will be also obtained at 2f. Okay, and 2f is positive, that is on the positive side of the lens. If you think the object distance is negative, that is left side of lens is positive, then obviously here the image distance is positive here, and here it is inverted one. So I am drawing it like this. So that is the image done by the lens. Okay, so the distance I am denoting here, the distance is 2f, distance is 2f. Okay, now let us do it. Anything regarding the mirror will denote by 1. This image 1, what is the found by the lens, it is acts as an object, acts as an object for the mirror. At what distance? Okay, the total distance is 5f and this much is 2f, so obviously this is 3f. The distance of the object, the image which is treated as an object, and that is at a distance 3f from this concave mirror. So we can say u1 object distance for the case of the mirror. u1, it is -1, obviously it is on the left side of the mirror, so -3f. And the focal length, obviously it is also -f. Okay, the image that we need to find it out. Okay, that we need to find it out. So question mark, I am writing down the equation for the mirror. 1 by v1 plus of 1 by u1 equal to 1 by f1. So what is v1? We need to find it out. Obviously I have not put any kind of sign convention here. So when the v1 will comes out, it comes out with the sign convention. Okay, so 1 by v1 plus u1 is -3f, 1 by f1, so this will become minus of f. So 1 by v1 minus of 1 by 3f equal to minus of 1 by f. So 1 by v1 equal to 1 by 3f minus of 1 by f. So from it 1 by v1, you can take 3f as LCM. So it is 1 minus of 2 divided by 3f. So from here v1 equal to minus of 3f divided by 2, or you can see it is minus 1.5. So obviously it is in front of the mirror on the left side of the mirror, and the image is inverted or erect. The image is inverted or erect. The final image, if you place the object at a distance more than 2f, you place the object at a distance more than 2f, here the image 1, that is the object 2, which is the served as the object for the mirror 1, which is at a distance 2f, greater than 2f, than that of the mirror. Okay, and we are getting the image in between f and 2f, so logic is satisfied here. So obviously if you say this is the f for the mirror, then obviously this is the 2f for the mirror. Okay, and the image is inverted, so the image will be like that, and the image is here, image is here. So that is the image formed by the mirror. Okay, so at first object 1 is placed in front of the lens. Object 1 creates the image 1. Okay, and this image 1 acts as a object for the mirror m. Now the mirror basically form the final image at the position image 2, which is at a distance 1.5 f, which is at a distance 1.5 f from the mirror. So this is the whole scenario, the combination of the mirror and lens, and that comes in 2 marks. Okay, so basically the questions are really competency based, really twisted, and lots of things here you have to do. Thank you all of you.